This is the spec for the second limit module. Limits 2. And here we're going to, besides to some degree reviewing what we did in limits 1, but we're going to introduce the idea of limits as we approach infinity, negative infinity, or where the limit as we approach some non-infinite number is infinity or negative infinity. And I think in this module, maybe half the time, or I'll leave it up to you, the module designer, to decide how often to show this graph paper and graph it. I don't think it should be all the time, because especially as we approach infinity or negative infinity, or the limit approaches infinity, or whatnot, it's easy to see what happens if you have a graph. But I want people to see that sometimes. So sometimes they should have a graph. So it very clearly says, hey, what happens as the limit approaches infinity, and the graph looks something like, maybe the graph looks something like this. The limit approaches infinity, they'll say, hey, it's approaching 2. And they'll just look at the graph regardless of what the function is. Or as approaching negative infinity, it's also approaching 2. But we don't always want this here. We want them to do it analytically, not just visually every time. So with that said, let's think about what type of problems we have. So first we have the problems where where x is approaching either positive or negative infinity. So we want to see what happens to its, what essentially, are there any horizontal asymptotes? So we could write f of x, and you could switch it up with g of x if you want. F of x is equal to, and these are generally going to be of the form of a polynomial and a rational expression. So you're going to have, let's say, 3x squared plus 2x minus 1. And let's say you have negative x squared plus 200. And so the first hint and then of course we'll ask the limit as x approaches infinity of f of x is equal to question mark. Now, the first time that they click hint, we could show something like this. They say divide the numerator and the denominator. Divide f of x's numerator and denominator by the largest degree of x in either. And if you want in parentheses, you could write, hey, because we are dividing by the same thing in the numerator and denominator, or we're multiplying by the same thing, we're not really changing the number. But that's optional. We'll explain that when I make a video on it as well. There are videos, but I'll maybe make a special purposed video for this. So then we'll get this. We'll get 3 over, actually it'll just be 3 plus 2 over, actually maybe we'll do one more step where we show what we're doing. So we're doing 3x squared plus 2x minus 1, all of that over 1 over x squared. And then the denominator will be negative x squared plus 200 times 1 over x squared. And then that's going to, so we could write f of x is equal to, and then we could write f of x is equal to 3 plus 2 over x minus 1 over x squared. All of that over negative 1 plus 200 over x squared. So this will be the first hint. And then we could say, look, if they click hint again, all of the terms with x in the denominator will approach 0 as x approaches infinity. So, and then we'd write the limit as x approaches infinity of f of x is equal to, we could say the limit as x approaches infinity of 3 plus 2 over x, well, that's a minus 1 over x squared, all of that over negative 1 plus 200 over x squared. So we could say all of the terms with x in the denominator, we could circle them or underline them, whatever is easier, or just color code them. So we could say that this whole limit is going to be equal to 3 over negative 1, which is equal to negative 3. And if this was if we, you could put a random variable so it only does it half the time. If you didn't graph it, we shouldn't even show the graph paper. If this is one where we're going to graph it, then we'll show the graph paper. And when the graph paper, this graph is going to look something like this. Actually, I don't know what it's doing all of when it's doing as on negative values, but the graph, we know that the asymptote as we approach infinity. Let's see, is it going to be a positive? Well, it's going to approach from, it's approaching -3, and is it approaching from above or below? Well, I'm just, let's say the graph looks something like this. I don't know what it looks like. So that's one case. We're approaching infinity. We could also ask what happens as we approach negative infinity. We want to put polynomials of various degree here, as long as the graph shows up here. And these can be random number, random number. That could be a random degree. Maybe we go up to 3 or 4, depending on what you want to do. But that's generally the case where we're dealing with the horizontal asymptotes. Now, the other situation is where we're taking limits. So here we would do, this would be as x approaches infinity or negative infinity. The other situation is where we are taking a limit to some finite number, but the limit is either positive or negative infinity, or it does not exist. Or it does not exist. So a case like that would be the limit as x approaches 2 of, I don't know, we could just say of 3 over x minus 2. And so this one, if you were to graph it, but remember half, and we could put a question mark, equals question mark. And regardless of whether this is the case where you graph it or not, on the problem you could just literally say, oh, maybe we could write it this way. Actually, this would be even better. No. So we could say f of x is equal to 3 over x minus 2. And you could switch it up however you want. Limit as x approaches 2 of f of x is equal to question mark. And then you could say approaching 2 from the left, we get, you could either do a table, or you could say f of 1.9 is equal to whatever that is. It's what? It's like 30, right? No, it's let's see, it would be 0.10. It'd be -30. F of 1.99 would be -300. F of 1.999 there is equal to -3000. And so it looks like, not very rigorous, but it gives people the gut sense, looks like f of x, it looks like, and we could even introduce them to notation, looks like the limit as x approaches 2 from the negative of f of x is equal to -infinity. And then if they click hint again, approaching x from the right, we get, and then we get f of 2.1 is equal to 30. F of 2.01 is equal to 300. F of 2.001 is equal to 3000. So once again, you can say it looks like the limit as x approaches 2 from the positive direction of f of x is equal to positive infinity. And then if they click hint again, since the limits are not the same, since the limits from the left and right are not the same, the limit does not exist. And you could write that down instead of having to parse my messy handwriting. And of course, in all these cases, you could put infinity, negative infinity, undefined, instead of a not doesn't exist. That's better than undefined for limits. Doesn't exist. You could put in some, 2 and 8, and it's up to the student to figure it out. So in general, this one, it doesn't exist. But if we had done something like 3 over the absolute value of x minus 2, then it would have existed. Then it would have been a positive. It would have been a positive infinity. So they mess around with the functions, give as many different types of functions as possible. But when you give them a lot of random numbers, they'll look like more than necessary, or more than enough. You want as much variety as possible. And so that's the limits to module. And only show the graph maybe half of the time.